Let's talk about the cardiac output. The cardiac output refers to the volume ejected by one ventricle in 1 minute. Okay. Again, both ventricles must eject the same amount of volume, otherwise the blood will back up in the heart. So it doesn't matter which ventricle you use, you should get the same value. And it's equal to how fast the heart beats, your heart rate, times how much blood is pushed out per beat, which is your stroke volume. So assuming that your resting heart rate is 75 beats per minute, and a typical stroke volume is about 80 mLs. Okay, that would give you a CO, a cardiac output, equal to about 6 liters, which happens to be the amount of blood in the entire body. So basically, in 1 minute, your entire blood has gone through the heart, through both sides of the heart. Okay, so and imagine if you have a higher heart rate, that means in less than a minute, your entire blood has gone through the heart. So that's CO, around 6 liters per minute. It's pretty fast. At rest, that is. Okay. There's something called your cardiac reserve. Your cardiac reserve refers to your ability to increase your CO when needed. Okay, is the ability to increase CO, meaning your reserve is equal to your cardiac output when you're exercising. When you exercise, you must push more blood out to get to your muscles, which are working. Subtract from that the CO when you are at rest. Okay, so we want to know if your heart is capable of upping the CO when needed. Okay, so usually this reserve, the CR, can be about 4x fold. So a normal, healthy person should be able to increase their cardiac output by 4-fold. So if it was 6 liters per minute, they should be able to get it up to about 24 liters per minute. Okay, up it, because you need it. You can, if you are, say, an athlete, and a well-trained athlete can go as high as 7 times. Okay, 7-fold increase. If you have, say, a weakened heart that cannot adjust to pushing more blood out, this is what this test is for. So now, if you have a weakened heart, it's almost the same. No change or a little change for a heart condition or weakened heart muscle. So that's the value of the cardiac reserve. It's an indication of how healthy your heart is and its ability to up the output when demanded for it to do so. Okay, let's move on to blood pressure. Blood pressure is a measure of how much force the blood imparts on your blood vessel when the heart squeezes. Okay, so BP is the force of blood against your blood vessel. Normally it's done, or the units of measurement is millimeter of mercury. Okay, and these BP values, and it's normally taken in arteries. Blood pressure is measured from arteries, not veins or capillaries, because it's highest in the arteries, and that's what we're interested in. So your values are, so there's something called your systolic pressure. Systolic pressure, or your SP, is the maximum pressure obtained during systole. So when the heart is squeezing to push blood out, the maximum pressure during that time is called your systolic pressure. Your diastolic pressure is the minimum pressure obtained during diastole. So when the heart is relaxing at its lowest point, what is that value? Obtained during diastole. Okay. And usually when you get these values given to you by your nurse or a physician, they give you two numbers. A high number, so the top number, over the low number, that is. So maybe say 120 over 80. That's the typical way of expressing blood pressure. SP over DP, okay? There's another value as well called your pulse pressure. The pulse pressure is the difference between SP and DP, equal to SP, systolic pressure, subtract diastolic pressure. That's the pulse pressure. PP equals that. And this is what you feel. So whenever you take a pulse, you feel a pulse because you have SP, DP. As SP pushes the vessel up, DP drops it down, so it pulses. Okay, that's what we call the pulse pressure. And then there is something called the mean arterial pressure. That is the average pressure. Average pressure during a cycle, during a cardiac cycle. Because during a cardiac cycle, you have diastole and systole, so the pressure changes. So we want to know the average pressure over that 0.8 seconds. And that's equal to 1/3 of the pulse pressure plus the diastolic pressure. Okay, that's how you get the mean arterial pressure, which is the average pressure felt by the blood vessels in one cardiac cycle. Okay, let's give some other specs on blood pressure while we're here. So blood pressure is controlled by what's called your baroreceptor reflex. Okay, how to control blood pressure. Control of blood pressure. So if this is your heart, this is your aorta coming out and going down, aorta. There's also there's also a branch off the aorta that goes up, right, to form your carotid artery. So this is your carotid artery. This is your aorta. So in the aorta, you have specialized cells here. And also here in the carotid sinus. And these specialized cells are called these are basically your baroreceptors. So your baroreceptors are located here and here in the aorta and the coronary sinus. And these receptors can convey information to your heart, to your brain, through cranial nerve number 9 and cranial nerve number 10. Okay, and this information is relayed to an area of the medulla oblongata, where it's called your cardiac center and your vasomotor center, meaning it controls your heart rate as well as your blood vessels. Vasomotor center and cardiac center in the medulla oblongata. And then these two areas will then send out commands to control your heart rate and your blood vessel diameter. All right. So let's see how it works. So what we call your baroreceptor Here we go. An increase in blood pressure will trigger the baroreceptors, increases, your baroreceptor activity, which then convey through nerve 9 and nerve 10 to your cardiac center, as well as to your vasomotor center. Your cardiac center, in response to high blood pressure, will cause the heart rate to drop. So you drop your heart rate and also drop what's called the force of contraction. Your contractility also drops. Force of contraction. While your vasomotor center will cause your blood vessels to dilate. Okay? And then both of these responses here will lead to a drop in blood pressure. That's how this reflex works. And it works the opposite way if it's a drop in blood pressure, right here, then this activity drops. And over here, now the response will be that you will cause the heart rate to go up, and your blood vessels will constrict, vasoconstriction. That's what happens when you have an increased blood pressure. Sorry, a drop in blood pressure. That's your baroreceptor reflex. And let's wind this down. Look at some normal values for blood pressure. Okay. So blood pressure. There's something called hypertension. Okay, that's when your blood pressure is below normal. So here, SP values, DP values. So if you're hypertensive, which tends to be actually can be good for health, that's when you are less than 95 SP, less than 50 DP. That's hypertension. Normal blood pressure values should be less than 120 for SP and less than 80 for DP. You're said to be pre-hypertensive. Okay, pre-hypertensive if your SP is below, so if SP is between 120 to about 139, you mean you're in the early stages of hypertension. And for DP values, it's 80 to 89. Then you're in stage 1 hypertension. If you're at 140 to 159 and 90 to 99, you're in stage 2 hypertension. If you are greater than 160 and here greater than 100 in the DP values, and you're in crisis mode, and hypertensive crisis, if you are, I think, greater than 180 and here, I think, greater than 110. Let me make sure I get those numbers right. Okay. So please note for me these different levels of hypertension and what the values are that correspond to these stages. Okay, that ends our lecture on the system, your cardiovascular system.